managing budgets. Sorry. So two main areas we're going to cover are going to be around managing budgets and costs. So this is going to be around ways to maximize the resources that you have in Azure Machine Learnings. What are different kind of tips and tricks to optimize your computes? What exactly you pay for in an Azure Machine Learning workspace? Different policies you have the ability to set up to kind of control, manage your costs, where you go in your Azure kind of subscription to see the costs and the breakdown of the different costs. That's going to be one section, the first section. The second one, we're going to talk about actually how to set up your workspaces. So Workspace is the kind of the highest level of unit within an Azure Machine Learning environment. That kind of is kind of a container of all your resources in one place where you kind of run your jobs, do your deployments, run your experiments. And we're going to talk about different considerations in managing those workspaces, when you're training, kind of things to keep in mind when you're deploying models and you're trying to set up inferencing and scoring based on where your users are, what to keep in mind when you're setting up the workspace. So let's get started on the first section, managing budget, costs, and quotas. So we're going to talk about, like I said, picking and optimizing compute resources and kind of viewing the cost. The second section is going to be around job priorities, early termination of runs. And the last is going to be around kind of monitor computes, quotas, and policies you can set up. So to get started, so what are the costs that are actually incurred in a workspace? As I said, so some of you guys may have already kind of created POCs in Azure Machine Learning or are exploring different use cases. Typically, the costs are breaking down into four areas, right? The biggest hitter is going to be your compute cost. So compute costs are going to be incurred when you're, both when you're developing and training, and also when you're kind of deploying your models and setting up an inferencing endpoint, you're going to use your computes. Computes are, essentially it's just a VM you get, right? And there's different options you can select, for that VM within Azure Machine Learning, which we'll talk about further. Then there's workspace level costs. So technically, compute costs are part of workspace level costs, but I broke them out because, compute costs are just, there's so much there. But the other costs around workspace level costs are things like application insights. For example, when you're trying to monitor your models, how many requests is it getting? What's the failure rate? What's the response times? Things like that, you're going to be charged for as you use them. So when you're looking at your Azure build within Azure Machine Learning, you'll see these different elements. Then there's cost around inferencing endpoints, as you mentioned. So specifically, you obviously inferencing endpoints going to have a compute cost, but also if you need load balancing, for example, if you have high workloads when you're kind of inferencing and scoring is happening, at that point, you may need something like Azure Kubernetes Service. And that's going to have costs associated with it, which are going to be separate. So then lastly, you've got your storage, model, and data register costs. So these are basically the data that you're registering, both for the data that you're going to use for training and development of your models. And then once a model is built, that in itself is going to comprise of some data. And you have to kind of store that model somewhere. So, in terms of which compute size to choose. So when you're starting, and if you are in more of a POC phase, these are the two computes Microsoft suggests. As you can see by the specs, one is a CPU based, one is a GPU based, and the specs, for the CPU based, it's 4 cores, 14 gigabytes of RAM, 20 GB storage. It's not so much, right? So when you're in your kind of development phase of kind of you're training your data, these specs you can get on kind of a laptop, right? So one thing to kind of keep in mind is, maybe when you're starting your kind of development and training, one way to kind of, minimize costs is to do development locally, right? Do development with a sample data set on your local machine. And as you need to do, training on a larger data set, then you shift to Azure for using the computes. Now, where does that not work? Right? If you've got some security considerations of your data, maybe there's some personal information or policies of your organizations where you cannot have your your development team have copies of production kind of sensitive data on your workstations. In that case, using Azure, Azure Machine Learning as a place where, as a data repository and a central place where users work, where you don't have to have data in your, the workstations of your development team, then this is still a valid option to use the compute both for development and training with the data that's already there in Azure Machine Learning. So as you notice, there's two types of computes I mentioned. One is a CPU-based, one is a GPU-based. These are like different VM families Microsoft gives you. So GPU-based generally are better for kind of high image computation. They allow parallel pixel processing, and for deep learning models that are doing image classifications, GPU work well. On the other hand, CPU-based, within CPU-based, Microsoft gives you kind of different options around memory optimized, which basically just means compared to the compute, the memory is larger. And for the larger memory, it's better for large training data set. As opposed to the compute optimized, it's mainly just the focus is more on compute relative to memory, and they're better for tasks that are kind of latency sensitive, real-time inferencing, where you might have multiple requests on your model to score that model, where compute is more of a priority. So we talked about picking a compute size for like starting up a POC for more like development or training. Now we're talking about what type of compute you should pick when you're trying to do inferencing. And inferencing, maybe I glazed over it earlier on. What inferencing basically means is, when you're at a point when you're scoring new data that's coming into your existing model, right? So you have your training data, you have your data, you use your data to build a model, the model gets created, and now like new data is coming into the model, and then that model has to give an output or prediction based on the training data. It's going to score the new data. That's what we mean by inferencing. So you have different types of inferencing. You've got real-time versus batch. Real-time inferencing, think examples like chase fraud detection, right? So when you have, we're all kind of swiping our cards, and there's millions of transactions happening, throughout the U.S. and the world, and they've got models that are kind of scoring each transaction and spitting out an output. I mean, those are real-time inferencing capabilities, right? So the model needs to be able to kind of get multiple requests at one time and give a output to your customer. So within the first step, obviously, is to get started, using profiling capabilities. Look at your usage. We'll talk about different monitoring capabilities. Sorry about that. Different monitoring capabilities, later on in our slides. What's a utilization of your computes? But general rule, like Microsoft gives a recommendation, if you have high availability for inferencing, you should use Azure Kubernetes Service. Why? Because Azure Kubernetes Service has the ability to kind of add load balancing and scaling, right? So and the general rule is if you have less than 10 queries per second, you use a CPU SKU with kind of an F-series SKU, which is kind of a lower grade. But if you have greater than 10 queries per second, Microsoft recommends, especially with deep learning models, using the GPU SKU. So we talked about earlier about, when you would use CPU versus GPU. So these are recommendations coming directly from Microsoft, depending on, how many queries per second you're getting, right? Just remember the difference between with machine learning. When you hear about Azure Kubernetes Service, AKS, Azure Kubernetes Service is used when you're kind of deploying and you're doing inferencing, and Azure Kubernetes Service has the ability to scale, right? So as you get more requests, it can scale up and down. So with machine learning, Azure Kubernetes Service, just equate that to scaling. And, that's why the mention of, queries per second, how many queries there are, and that comes into play in your decision to be able to use it. The type of SKUs you would use. So the second type of inferencing we talked about is batch inferencing. So batch inferencing, we're really talking about things, obviously, that are not like latency sensitive. So I would, think like your Netflix recommendations, your Amazon recommendations, those are likely batch inferencing. I don't think when we log into Amazon or Netflix at that moment, they're doing kind of real-time inferencing. They check, okay, what's the new recommendation to give? Chances are those are probably kind of calculated, in a batch process, and they're given to us, the next time we log in, and they're already stored. So batch referencing are not real time. They're they're less latency sensitive. So the kind of recommendations there is, to speed up batch inferencing jobs is mainly doing parallelization, right? So parallelization of tasks that Microsoft gives you, within the VMs to kind of scale out horizontally. And obviously that has to do with kind of any parallelization task. There aren't any dependencies where kind of one job is, dependent on the other, and where possible to run multiple jobs at the same time. And obviously with any parallelization, if you kind of distribute tasks on a number of nodes, the more you scale out, the more nodes you have, smaller nodes you're using to run tasks, there's going to be overhead to then take that data that those smaller nodes are processing and kind of compile it together. So those are considerations to keep in mind for batch inferencing. So earlier we talked about what you could possibly pay, in this slide, what you could possibly pay as part of a workspace, right? Compute costs, workspace level costs, inferencing endpoints, storage. But you're not going to pay for these things all the time, right? It's only when you're using certain things you'll pay for them. So now in this slide, we're digging deeper into just the compute instance. When you're running a compute in Azure Machine Learning, what do you pay for, right? And that's broken down. So as I said, a compute is like your core, one of the core costs of your Azure Machine Learning model, right? That's where most of the costs are incurred. When you're kind of doing your machine learning, building your machine learning models. So for a compute instance, basically what you're paying for is a VM, right? That has the specifications that you choose. There's a load balancer, with inbound outbound rules and for the data that's processed. There's OS disk, for the operating system, obviously that's running on the VM, right? Because the VM's gonna have an operating system. There's premium SSD managed P10 disk that's running on. Temp disk, which is, as you're using it, you utilize the temp disk space and a public IP address. So there's a distinction. So a compute instance, as we discussed, as you're doing your development, you're doing your training, or you have a compute deployed to do your inferencing or store, you'll need a compute in all those cases, right? So you know, you can turn computes on or off, right? So if I'm, you know, doing like a heavy training job, I can have a compute on. Once that job is done training, you know, I can turn it off. However, once you start or stop a compute, you know, that VM that's running, the operating disk space and the storage for the operating system, that still persists through start and stops. So you're, even though you may stop a VM, stop a compute, you're not going to pay for, you know, these other things, but the OS disk, you're still going to pay for it, because the operating system, Microsoft is not deleting that, right? That you still pay for. So, you know, as you guys are doing POCs and you kind of turn off your VM and you're still getting charged for, you know, there's still bill being accrued, you know, thing to keep in mind, you know, even when you have a compute turned off, you're still being charged for the OS disk that you know, persists through start and stops. Now, obviously, if you delete a compute, you're not, you totally, then you wipe out the OS disk and you're not charged for anything. So what are the compute options and costs defined per VM? So when you kind of go in to set up a VM, Microsoft, you know, gives you, you know, different, as we talk about different CPU and GPU families, and then there's, within each of those, there's different options and kind of sizes of VMs you can pick. As you mentioned, there's, you know, some memory optimized, compute optimized VMs, and you're basically charged, and this is, you know, standard in Azure, you're charged per hour for the compute that you use, right? And these are costs, if you're running it, you know, at kind of running it and using it, you know, throughout for that hour. So if you have a 5-hour training job, you know, 29 cents per hour for a, you know, DS3 V2, you know, 5 hour, $1.45 to, you know, to run that VM. So so as you're setting up your, you know, like your, let's say you do a POC, then you're trying to scale it out, and now there's going to be multiple development teams maybe using Azure machine learning, and it's going to be kind of used on a more enterprise level. One kind of useful feature is you know, setting up budgets in Azure. So this is not just for machine learning. This is, you know, at your Azure subscription level, and but you can pick, you know, the type of resource you want to set that budget up for. So if you see my screen, I've got a filter here, you know, in my subscription setup for, you know, Microsoft Machine Learning Workspace that I have, and I can set up budgets for them, right? So, you know, the benefit, obviously, of a budget, you know, is to be able to look at kind of cost across that you know, that resource type that you set up, and also it doesn't necessarily, like, you know, like if you set up a budget, if you hit that budget, it's not going to stop that resource, right? It doesn't budget, this budget option, it doesn't stop a resource, but it sends you alerts. So you can get alerts when those budgets approach like a certain kind of percentage. So I can set up a budget, you know, for my workspace, what I think a monthly kind of my limit is. And if I hit 80%, 90% of that budget, maybe there's some kind of rogue job, you know, running someplace, then I want to get notified of that, you know. So that is like a very useful feature when you're kind of managing your workspace and managing costs to actually set up a budget for it. So cost monitoring. So, you know, cost monitoring, it's basically the same location where you go for all your services. You know, you can monitor your costs. You go to your account level in the cost management, cost analysis tab here. You know, you have the ability to kind of look at your cost across a various various categories that Microsoft gives you. I have it by you know, the service name. You know, I use Synapse Analytics, virtual machines, no service name. This is just the pay-as-you-go subscription for the one that I have the screenshot for, the per month cost, your storage, virtual network, load balancer, container registry. So you can see all those costs that you're, incurring, in your Azure cost management tab. And you notice I mentioned I have a budget. Like my budget per month, is a $225 budget that I've set up for my subscription. So if for some reason I, turned on my computer and I forgot to shut it off and kept running, and it kind of approaches my budget, I'll get a notification on that. So what are the options we have to optimize our compute? So first option, with most Azure machine learning services that you use that, in analytics or outside analytics, is to start and stop compute, like simple. And that, Azure machine learning is no different. That's one of the kind of the flexibility, being able to start and stop compute is one of the kind of major reasons why, the cloud can be an attractive option. So that's number one. Specifically for machine learning workloads is that, another way to maximize, optimize compute is to be able to kind of work with a subset of your data, when you're developing models. And as we kind of mentioned earlier, work locally. And as you kind of prove out your model, kind of maybe do some feature engineering and, kind of parameter tuning, and you, with your development data, maybe for larger kind of training jobs where we need to scale out to kind of compute clusters, or kind of more powerful compute options that you cannot have on a local workstation, or you don't want to procure a separate server for. Then you go to the Azure cloud, for machine learning compute to process those jobs. So try to use your work with small sample data when you're developing your models, and try to train and develop locally wherever possible. The second set of options is around kind of auto scaling and timeout policy. So we talk about auto scaling, when you set up compute clusters, and you can set up your kind of minimum and maximum nodes, right? So when you're setting up a cluster, you have the option to say, as the job, if it's a large training job, it requires, you can scale up your compute clusters to run on multiple nodes as your jobs require. So as you're scaling, up and down as your job requires, you can go, to however many that the maximum that, based on your budget constraints that you want to avail. And, to set the minimum to 0. So when, the jobs are done, you come back down to 0. Now, when you do auto scale, that's not, if you're at 0 nodes, your compute is still running, right? So there's still going to be some cost there. This is not, when we say 0 nodes and you max out to, more nodes, that doesn't mean when you're at 0 nodes, you turn it off. That cluster is still going to be running. But it gives you the option of, as your training jobs become more, intensive, resource intensive, there isn't a bottleneck. You can auto scale, out and bring those kind of compute nodes down. Secondly, you've got your timeout policy. This is to turn that cluster off, right? Like, when do you want the cluster to be turned off? And this is based on your usage patterns. When you want to kind of turn off, turn your jobs on and off based on when your teams work. You can set up jobs, policies to kind of turn your clusters on and off. And as you mentioned earlier, when you stop compute, you're still paying for the OS disk space on that compute. So next, we're talking about job priorities and cost. So there's something that Microsoft gives you, or the option to set up is kind of low priority VMs. And basically, they have a quota separate from dedicated quotas that are that give you options per VM family, right? Like we showed earlier, when you're setting up a compute, you have the option to select a kind of standard DS 312. You also have the option to select low priority computes as opposed to dedicated computes. Now, what's the benefit of setting low priority computes? So when you have batch jobs, so jobs they're not latency sensitive. Microsoft, you can set up these Microsoft the low priority computes to make use of surplus capacity in Azure, and that's what Microsoft gives them at a discounted rate. The caveat there is when you set up those low priority computes, if a higher priority job comes, the low priority computes give priorities to those jobs. So, when you're the typical rule, to leverage the low priority VMs is when you're scheduling production jobs, you probably want to do it on, your dedicated computes. But when you have experimental jobs, when you're using AutoML and you're trying to kind of score different models or other kind of training development tasks, maybe that's a good kind of candidate to be able to use the low priority computes. And even beyond that, for jobs where latency is not an issue, you can even run them on lower grade VMs to maximize the use of those computes and kind of minimize the cost of those computes. So and by lower grade VMs, like the size of the VM, right? So use a low priority VM and then use a lower size low priority VM, right? To maximize your the compute, if your job allows it, like with Microsoft's recommendation around using it for batch jobs. Next option is around early terminating development runs. So, most of your jobs, when you're running models, you have multiple cycles, epochs that are running as you iterate to the best performing model, right? And you may have a job to run, 10 epochs and through each epoch, maybe the performance might be improving, right? Now, let's say you're running a job with 10 epochs and your accuracy after the first epoch, second, third, fourth is still like 50%. Chances are it's not going to jump up to like 90%, in the next epoch, right? Through that run. So, you can early terminate development runs. You can set up, rules to terminate a cycle based on a threshold you measure. Say, okay, if I'm running a job for this many epochs, if I don't get the type of accuracy thresholds that I have, I don't want it to run the rest of the epoch, the rest of the cycles, right? So when you're doing development, that's another way to, to kind of save costs that in Azure machine learning, that option you have to early terminate development runs. So we were earlier talking about, monitoring your compute performance. So basically for like when we mentioned, your real-time inferencing, how do you, if you have greater than 10 queries per second, less than 10 queries per second, you've got different kind of categories, around CPU utilization, how much your CPUs are being utilized, how many computes you have out there, how many computes are being used, like are all the computes that you have, are they being used, to maximum capacity or not? So those questions, using in your machine learning workspace, you go into the monitoring in the metrics tab. You've got the ability to look at various metrics to kind of give you some important details about your environment. So over here in my screenshot, I have it at the resource resource metric type, which is compute utilization for GPU and CPUs that are running. But you have information about the models deployed, models registered, quota details, as I mentioned, active and idle nodes, canceled and complete runs. So you can monitor the activities in your workspace over here. And then, if you make some adjustments, you can kind of, this can give you kind of insight into making adjustments, into those computes that are running, are you running at full capacity or not? So around Azure Policy to control costs. So when we talk about policies, Azure policies to control cost, what we're really just talking about is, what type of resources that can be deployed. So, at your workspace level, you're able to set up policies to allow, for usage of specific VMs. So you can control selection if, the expensive VMs, like the GPU-based VMs generally are a lot more expensive, than the CPU-based VMs. We showed the example of a CPU-based VM is around 29 cents per hour. GPUs, they start at over $1 an hour for GPU base. So you can control selection of your expensive VMs or enforce usage of the low priority VM SKUs. And as you mentioned on the previous slides, you can monitor the quotas are being best used, and allocate across machine learning teams by looking at the capacity, monitoring the capacity, monitoring how much of your CPUs that you have provisioned are they being used at the full capacity or not, using those monitoring capabilities I showed earlier. So here around example of kind of setting quota limits. As you saw here, I've got kind of my dedicated quotas. I've got my low priorities quota and my cluster quota. Like my maximum quota, I've got 6 cores defined, for my dedicated quota. And I set up a VM, in my a compute instance with 4 quotas, and now I have 2 remaining. So for my, this is for my pay-as-you-go subscription, I've got, by default, you get kind of 6 cores. And if, you can request an increase of that quota, but depending on the type of subscription you have, there are certain default quotas that Microsoft gives you, which you can request increase of. But that set of quota, then, you can distribute. You can set those up based on kind of your budgetary needs, and then that's a good tool to like limit usage of the resources that you have. So around the next topic is going to be around organizing your machine learning workspaces. So what we really mean by that is, there's kind of 2 elements that impact it, right? One is when you're setting your workspaces, the first element that impacts is your team structure. So, basically, like how are your budgets allocated, right? Like if you have, like budgets allocated per team, or you have budget allocated, per project, who can access what, that determines how you set up your workspace. And we talk about, different kind of considerations that are involved there. The second aspect that we're going to touch upon around kind of, kind of managing your workspace is around, where your data resides and where your customer resides, because depending on which region you create your VM in, your workspace in, you want that to be closer to your data, versus where you deploy your models, you generally want them to be closer to where your customers are. So there's a couple of options there that we'll discuss in that in this section. So team structure and workspace setup. So really there's depending on how you kind of structure your team, there's 3 options. You can have one workspace per team, right? Or you can have one workspace per project, which is kind of a more granular level than team, because one team can be working on multiple projects, right? So, one workspace per team, it's more high level. One workspace per project is a lower granularity. And the third option is kind of single workspace across teams. So we're going to talk about, each of these and kind of what they mean. So one workspace per team, essentially within a workspace, all artifacts for that team, are stored in that place, right? So, and as we mentioned in the beginning, the workspace is like a single kind of unit where cost can be measured, right? So what I showed earlier in terms of the cost you're able to see, across your workspace or budget, kind of the cost capabilities, across around your workspace, you can measure those. So if you have one workspace set up per team, you're able to track all the costs per that team easily if they're using just that one workspace. I guess another benefit also is that they're able to use all the artifacts that are created, for each other. So if you've got kind of data sets registered there, artifacts, kind of, models that are created, experiments that are done, you have them all in one place where all teams can use. The challenge is if you've got different projects that a given team is working on, you need more kind of naming conventions to allow clear identification of assets. If even within one team, there's one project that's working on one type of model, another project working on other type of working with other types of asset, one team working with other types of assets, you need naming conventions to allow clear identification of those assets. So if we go to the next one, workspace per project. So a lot of time projects are, the budgets are funded at project level. Projects are funded, and if you want to be able to track the budgets across that project, a good way is to set up a workspace per project. In addition, a lot of times you're relying on external developers to do work. You can just, you can just set up access for that external developer for that at the workspace level. They can see all the artifacts there. It's at the project level. There's no, concerns with them seeing other artifacts that maybe that team is working on, but outside that project. So, but along with that, the challenge comes around isolation of experimentation results and difficulty using, artifacts across teams. So, like I said, the same thing we mentioned as a benefit in the approach above, any data sets that are created, any models that are generated, any experiments that are run, across teams. Like if a model is generated, that's in one project, you want them to share with, in one workspace, you want to share with other members of your team that don't have access to that project. You got to kind of export that model out and for them to see what's, to be able to use that artifact. So, but it's really how you're deploying, how you're managing your budget that you weigh the cost benefit in each of these cases. The last option, single workspace across teams, that works well for more like R&D projects, and probably if you guys are in early stages when you're doing POCs and kind of proving out use cases, this is probably where a lot of folks will be when they're starting out. With kind of single workspace across team where you're kind of doing just R&D, because specifically with machine learning projects, unlike other software development projects, when you start and you're doing data exploration, you don't know if you're going to end up, what you're going to end up with, that's going to be the level of use that's going to have, right? So when you start off with a kind of an AI machine learning projects, there's going to be an element of R&D, right? And when that R&D, a single workspace for those types of kind of tests is a good place to have a dedicated kind of like an R&D workspace where teams can just do data exploration. Now, and also if you've got a budget, you know, for larger organizations that've got like a budget just for R&D, that single workspace that works, you know, across teams is a good option. But like I said, this only really works where project-related work can be decoupled from non-project related work. So if there is not like an imperative to track cost, you know, across projects, and even there's work that can be decoupled, you know, from a project level, this is a good option. Now, compared to the first option of one workspace per team, this is probably it leads to the most cluttered workspaces, right? So you're gonna have a bunch of teams, you know, using the same workspace, you know, creating experiments, creating, you know, artifacts. There's a big chance to, you know, to have very cluttered workspace, kind of people kind of stepping on each other's toes there. So that's a consideration to kind of keep in mind if you're using kind of single workspace across team. But like I said, if you're starting out, probably this is where most people kind of start out. So, but these are for more advanced use cases when you have, you know, kind of more like an R&D budget. Resource setup and regions. So, as I mentioned earlier, you know, when you're setting up a workspace, you know, the question will arise, which region you should set that workspace in, right? And what are the considerations there? So there's kind of two main questions, as you mentioned, you asked. One is, where's the data resides, right? Because the projects and machine learning projects that you do are going to be around, are going to be the region where you're going to be doing the training. The data needs to be close to that region. If you have a lot of, you know, if the data is in different regions, there are options which we'll talk about there, but the closer you are to the training data, you know, the better, or the closer access you have to the training data, better. However, on the flip side, okay, now you trained your model, you develop your model, now you need to deploy that model. That model, you know, your data may be in one region, but that model, the users of that model may be in a completely different region. So the users of that model are going to be sending requests, you know, to your model for inferencing and scoring, and those requests need to be processed, and the latency for those requests are going to be dependent on which region you deployed that model versus where your users reside. So what are the options? So as we talked about, you know, your compute training, you know, should happen in the same region where data resides, right? So as you're kind of training your model, there's less latency, you know, when you're bringing your data over. And the option that I was kind of talking about earlier, if, you know, typically if like these are your workspaces, right? You have workspaces, Central US, West Europe, you know, Central India, for example. Most probably, you know, the original option I was talking about, if you have data, all your data is in one kind of region, you know, you have that the data closest to it, right? You work in the region where the data is, but you have the option in Azure to be able to, you know, have storage accounts shared at a region level, not at the workspace level. So this is a kind of a diagram showing that option where you have the option where, you know, the data is shared across regions, to be able to leverage, you know, the data wherever your region is. So now this is obviously for use cases where, you know, you have that need to have multiple regions, you know, and to require like a shared account across those regions. But once again, if the general rule, however, would be wherever your data resides, you want your training to happen in that region, to have your workspace in that region closest to have the least amount of latency. So as far as the second option of, you want, like we talked about, serving data to users, as we mentioned, we want that to be closest to where the users reside. So now there are some considerations when you're, once you've deployed the model, because remember, let's say you train your model, right? Your training happens here. Now you deploy the model in, let's say you've got users in 3 separate regions, right? You do your training in one region, right? Like we mentioned, you pick one region where you do your training, but you deploy the model across multiple regions. Now, what do you do when there's new data is coming in and there's data drift, right? Now new data is coming in, one set of data is coming against this model, another set of users is using this model, and another set of users is using this model, right? So you have 2 options. One is when it's time to retrain your model, right? Like, so within your ML ops, right? Like, as traditionally in your ML ops settings, you keep monitoring your models. You keep monitoring the accuracy. The model that I build now, is it working, just as well, 6 months from now, or is the accuracy, decreasing or not? So when you're looking at, evaluating that data drift, and you're looking to retrain the model, do you want to kind of aggregate data across all 3 kind of user bases that have been used the model, retrain it back on the same data set, and then create one big model, then redeploy it back to each of these regions? Or, that's where we're talking about the option A, but option B, you can also have use cases where the training happens here, you deploy the models, but as each of the data comes in each of the regions, you go ahead and you fine tune and you retrain the models based on the data that's coming in that region, right? So, those are kind of considerations to keep in mind as you're kind of deploying and you're thinking about your, training pipeline. So in use cases where I've kind of seen this option in around being able to, if you've got equipment, that, you may train data on kind of one set of data, but then different, each equipment is generating its own, each piece of equipment is generating its own data and logs about its performance. So you can have the ability to kind of train a model based on that equipment and that equipment's data that's generating to assess whether that particular piece of equipment, needs to, have a model that's suited to that particular piece of equipment. So that's an example where, you want to fine tune the model, more narrowly versus have like a broader training set that's used across, the different types of users. So in conclusion, the recommendations that that we have that around managing your workspace. If your solution has a budget associated with it, you want to create a workspace and have associated storage completely separate, so you can allocate budget to that solution. As you mentioned, if you have like a common R&D budget that's available, multiple teams can use, have a workspace allocated to general use, with that central R&D budget. And if you need to, let's say a budget in R&D workspace that you're doing that then needs to scale, right? Then you can explore option of having a separate budget for that kind of given project, separate workspace for that project that's going to require it, but use the R&D workspace to kind of run some kind of exploratory analysis and then move it out to like a dedicated kind of resources to kind of track the performance of that project and in its own dedicated workspace. And lastly, as we mentioned, try to do your data training in one region, which is closest to the data source, and inferencing in another region, which is closest, to your users. So with that.